Welcome, cosmic adventurers. Have you ever stared into the vast night sky filled with billions of stars, yet found yourself surrounded by darkness? What secrets does the universe hold in its shadowy depths? Join us as we embark on a thrilling quest to unveil why space remains an enigmatic sea of darkness, despite the glittering stars.
Hey there, Kjær. Odd eye, curious minds. And welcome to Mundicore.
Picture the cosmos, a vast expanse bursting with countless stars, each a beacon of light in the seemingly endless void. Yet, when we gaze upward, we're met with a canvas of deep black rather than a blinding, star-filled radiance. What secrets lie behind this cosmic veil of darkness? Let's probe the depths of space to uncover the fundamental principles of light and its celestial journey. As we embark on this exploration, understand that light, although speedy, has its limits and peculiarities when traveling across vast distances. The intensity of starlight diminishes as it stretches over millions of light years. Moreover, not all light reaches us. Some is absorbed or scattered by dust and gas clouds strewn across the galaxy. This interstellar matter acts like a filter, dimming the light before it can pierce the darkness and ignite our night sky. Further complicating our celestial view is the very nature of the universe itself, sprawling with stars and galaxies often so far apart that their light becomes isolated, a solitary flicker in the immense dark. Imagine each star as a distant lantern in a vast, foggy field, barely piercing the gloom. This vast distance means that much of the universe remains shrouded in shadows, invisible to our naked eyes and leaving us in a state of wondrous darkness. Enter the realm of the Olbers Paradox, a cosmic conundrum that has puzzled astronomers for centuries. Named after the German astronomer Heinrich Wilhelm Olbers, this paradox poses a seemingly simple question. If the universe is infinite and filled with stars, why is the night sky not ablaze with light? As we delve deeper into this enigma, we uncover profound insights into the age, structure, and dynamics of the universe. The heart of the Olbers' paradox lies in our perception of the universe's vastness and the infinite nature of space. In an infinitely old and infinitely large universe, every line of sight should eventually intersect with the surface of a star, resulting in an unrelenting onslaught of light. Yet as we gaze into the night sky, we are met with darkness, a contradiction that challenges our understanding of the cosmos. But fear not, for the resolution to this paradox lies in the very fabric of the universe itself. As we peer deeper into space, we encounter the concept of the observable universe, the portion of the cosmos that we can perceive given the finite speed of light and the universe's age. This realization sheds light on the darkness of the night sky, revealing that our cosmic vista is limited by the boundaries of time and space. As we venture further into the cosmos, we encounter one of the most profound phenomena shaping our understanding of space, the expansion of the universe. Picture the universe as a vast tapestry, with galaxies woven into its fabric. But instead of remaining static, this tapestry is ever-growing, with each thread stretching farther apart with time. This cosmic expansion carries profound implications for the appearance of the night sky. As light traverses the expanding universe, its wavelengths stretch along with the fabric of space itself, causing a phenomenon known as redshift. This gradual shift towards longer wavelengths can push light beyond the visible spectrum, rendering it invisible to our eyes and contributing to the darkness of the cosmos. But the story doesn't end there. The expansion of the universe also plays a crucial role in shaping our cosmic horizon, the boundary beyond which we cannot observe due to the finite speed of light and the universe's age. Thus, as the universe expands, it not only stretches light to invisibility, but also limits our ability to perceive the full extent of its grandeur, leaving us in awe-inspiring darkness. As our cosmic voyage continues, we encounter a relic from the earliest moments of the universe: the cosmic microwave background radiation. This ethereal glow permeates the cosmos, a faint echo of the universe's birth heralded by the Big Bang. But why does this radiation remain invisible to the naked eye, shrouded in the shadows of the universe? To understand the enigma of the cosmic microwave background radiation, we must journey back in time to the universe's infancy, mere moments after its explosive emergence. At this primordial juncture, the universe was a seething cauldron of energy and matter, too hot and dense for light to travel freely. As the universe expanded and cooled, photons, particles of light, were finally set free, creating a luminous fog that bathed the cosmos. Today, this ancient light is cooled to a whisper, manifesting as a faint glow in the microwave portion of the electromagnetic spectrum. But why do we not perceive this cosmic relic with our eyes alone? The answer lies in the limitations of human vision and the sheer scale of the universe. While the cosmic microwave background radiation envelops us, its wavelengths are too long to be detected by our eyes, remaining hidden in the shadows of the cosmos. As we stand on the precipice of discovery, armed with cutting-edge technology and boundless curiosity, we unveil the secrets of the cosmos through the lens of modern astronomy. With instruments that pierce the veil of darkness, we observe the universe in ways once thought impossible, shedding light on the darkest corners of space. Infrared telescopes peer through cosmic dust clouds, revealing hidden star nurseries and distant galaxies. Radio telescopes capture whispers from the depths of space, deciphering the echoes of ancient cosmic events. And space-based observatories, free from Earth's atmospheric interference, unveil the universe's most elusive secrets with unprecedented clarity. Through these technological marvels, we transcend the limits of human vision, venturing into realms beyond our imagination. We witness the birth of stars, the collision of galaxies, and the dance of celestial bodies across the cosmos. With each observation, we deepen our understanding of the universe and our place within it, illuminating the darkness with the brilliance of knowledge. As we conclude our journey through the mysteries of dark space, we are reminded of the incredible complexity and beauty of the cosmos. While we have explored the theories and phenomena behind the Olbers Paradox, it's important to acknowledge that many enigmas still await answers in the depths of the universe. Through science and continued space exploration, we can expect to unravel more cosmic secrets and expand our understanding of the universe. The mystery of dark space challenges us to question, to investigate, and to never cease seeking answers. So as we bid farewell to this episode, I invite you to continue your own journey of discovery and exploration. May the stars always shine upon your path, guiding you towards the yet unrevealed mysteries of the cosmos.